Hello everyone, this is Mithul, Automation Architect from Infrastructure Services. Today we will give a quick overview of in vivo automated intelligence. The agenda is we will give a quick overview of what autonomics is all about, how it works as an integrated platform with other tools like ServiceNow and Nagios. We will go into the architecture and followed by a quick demonstration of the workflow. Alright, so just a quick overview of automation, because this is a conceptual model of automation. What you see on the diagram on the left hand side is the Mars model, which is basically nothing but the IT environment. So every customer has an IT infrastructure which is represented in some format, and in Autopilot we have this in the format of Mars. Mars stands for machine, M stands for machine, A stands for application, R stands for relationship, and S stands for software. So this is basically a dependent model which is represented in Autopilot. What you see in the center is the knowledge. So Autopilot engine basically has a pool of knowledge which has been developed. What knowledge means is a set of sequence of tasks which are executed to resolve a particular situation, right? So in a typical IT environment, you would see a situation like a server going down or a service going down or CPU reaching 100% and so on and so forth, right? So the situational data is being fed into the Autopilot engine, and the Autopilot engine basically traverses and searches for the knowledge in the knowledge bank. Depending on the search outcomes, it does a pattern matching and actions the sequence of execution, right? So actions, what do you mean by action is it executes a set of commands on the remote infrastructure which is impacted, and depending on the outcome of the commands, it would give us the results. So results would be either the issue was or the situation was resolved, or the situation was not resolved. In case where the situation is not resolved, the automation engine would assign the ticket or the incident to the respective human engineer. So that's the conceptual high-level overview of automation, in vivo automation. Next is the prerequisites. So these are some of the dependencies, some of the critical prerequisites for automation to execute, to work, to function. Starting with the assumption is there is already some kind of CMDB in place. CMDB is one of the key component in ITSM. It basically stores the configuration items and the relationships between them. So that's the CMDB. And CMDB also comprises of the service model. When I say service model, it means the business service model, which comprises of the breakdown components starting from the server to the software to the resources and to the application, right? So that forms the CMDB, and CMDB is basically consumed by automation in terms of Mars model. The next is the ITSM system itself, which is basically comprising of your incident, problem, change management modules. So this is one of the source of information for Autopilot. So any ticket which is today created in IT environment, that becomes a source of consumption, or any change which is being created in ITSM tool becomes a source of consumption for Autopilot. So that's another prerequisite. The third is the event management system should be in place. So which means the IT infrastructure today is being managed and monitored by some kind of a monitoring tool, right? So it can be a BMC event manager, can be HP event manager, can be Nagios, and so on and so forth, right? So that manages, it monitors the respective host and the services, and depending on the impact it would generate an event or an alert, right? So any alert or any critical situation which happens would be recorded and would be consumed by the automation, right? So that's the another prerequisite. The other moving on to the next prerequisite is the knowledge item. So as I said earlier, knowledge item is nothing but it's a sequence of steps which are being executed to remediate or resolve a particular incident or an issue, right? So that's the another critical prerequisite. And the last and not the least is the access to the customer infrastructure. So Autopilot typically accesses the infrastructure of any customer using a secured mechanism. So we use SSH for Unix and Windows remote management services for for Windows servers. So moving on, this is the high-level architecture of the automation. So this is the integrated architecture. What you see on the left is the customer's infrastructure, which comprises of all the critical component servers, which is databases, routers, which is so these infrastructure elements are being monitored by Nagios, which is one of the monitoring system, right? So as you can see, there are agents which are being deployed on the infrastructure, and agents are basically monitoring each of the systems. So if any impact happens, it would generate a critical alert, right? The alert would basically be fed to the Nagios system, which is the component which is sitting here. Nagios would then forward the alert to ServiceNow. So event is basically converted to an alert, and alert, as you can see here, there is an instance, ServiceNow instance, which consumes the alert, and it transforms the alert into an auto ticket, right? So as I said earlier, the source of consumption for automation is either an event or a ticket. In this case, the event is converted to an alert. From alert, it gets automatically converted to an auto ticket, and the ticket would then be consumed by Autopilot. So here, if you see the in vivo stack, this is where we have written a connector which would consume the ticket data, which is the incident data. It will process the incident data, and it would recognize that there is an incident which has happened. It would then look into the knowledge bank, identify that this is a known issue, and execute the remote command. So we can see there is an execution call which is going on, right? So the command would be executed directly on the remote target, right? So whichever component has been impacted, we will see the appropriate knowledge item having an appropriate execution command to remediate the situation. It would execute on the target, and it would resolve the issue, right? So all this is a closed loop communication. Once the incident has been resolved, the event or the alert would get closed, and Autopilot would also update the status of the ticket to the resolved status, right? So this is a very high level overview of how automation works in tandem with the other tools. Okay. Moving on, we will demonstrate a couple of use cases. Some of the use cases which are related to incident and request management. We will demonstrate the MySQL or Tomcat services which is impacted in the infrastructure, and we will see how automatically the ticket has been created and how Autopilot consumes the ticket and resolves the issue. When I say it resolves, it means it brings the service up and running. So we will see that in the demonstration. The second one would be for the event correlation. So here we will see there are multiple event being generated, but Autopilot is only interested in consuming the root cause event, right? So we will see a scenario where there is a correlation between two infrastructure element, but the root cause element is something which we are interested in. So we will extract the event, which is a root cause event, and we will see how it remediates. Okay, so to start with, we will start the first demonstration of MySQL service. So as you can see, this is my Nagios monitoring console. This is a typical console which a NOC operator would be watching on a 24/7 basis. As you can see, I'm currently monitoring a host named as CentOS_M, and on this particular host I'm monitoring also a lot of services, MySQL, SSH server, users, and so on and so forth, right? So what we are interested is we will see the MySQL service getting impacted, and how the automation engine would pick up the ticket and how it would resolve automatically. We will see that in a minute. Alright, so so I am already logged into my CentOS server right now, and for demonstration purposes I would bring the service down, the MySQL service down. Before that, I would like to show the service is currently running. So as you can see, service MySQL status, it shows the service is running, up and running, the status is okay. And what I will do is I will bring the service down. In real world, this would happen, the incident can happen at any time, right? So service MySQL stop, and it is shutting down the service. If I see the status says the MySQL service is not running. Right, now I go back to the Nagios console, and if I see the status in a minute, it should turn as critical red. There you go. So as you can see, the MySQL service has the status has turned as critical red. And what happens next is the moment the critical event has been created, alert would be generated in ServiceNow, and it would also lead to creation of a ticket, right? So I will go to the ServiceNow console and I will check for the incident. So as you can see, the ticket has been created, MySQL is not running, and if I open the ticket, it is automatically been assigned to the InVivo group. InVivo is nothing but the automation group, and assigned to InVivo user, which means the ticket has already been assigned to the automation engine. It has also automatically filled up all the required attributes like database, tier 1, tier 2, tier 3, which is nothing but the database. Also the product name has been populated automatically, and the configuration item, which is the CI, in my case it is CentOS_M, that's also been populated automatically, right? So the ticket has already been consumed by autopilot. It has researched the knowledge pool, and it has found the right knowledge item, and it has also executed the commands on the remote target to bring the service up. So we will see the status of this particular ticket getting changed to resolved. So if I go back again, there you go, the status has already turned as resolved, right? If I go back to the ticket again, it will show me that status has indeed turned out changed to resolved status. Right, now if I go back to my target, if I check the status, service MySQL status, it is up and running, and if I also check my Nagios console, it will show the service has been restored and it is turned green, status is also okay, right? We will now go to the autopilot console. This is the cockpit. In the cockpit, as you can see, I have already got a service model. This is the Mars model, as I explained earlier. This is the Mars model for the operating system which I was talking about, CentOS_M, which is basically hosting MySQL and Apache, and MySQL was the node which was impacted, right? And this particular node is basically serving one of the critical business application called as PeopleSoft HR service, right? So you can imagine in real world, if one of the node goes down, the entire application would also go down, right? So within minutes or within a fraction of seconds, we saw the resolution. The service was restored, the alert was closed, and also the ticket was marked as resolved. All this happened in a fraction of minute or seconds, right? We will see the sequence of execution which took place in autopilot. So I will show you the simulation. For showing the simulation, I have to copy the ticket ID. And what I will do is I will search for the ticket. So I have copied the ticket ID, and if I search, I can get the result. I got the ticket. So as you can see, the ticket has already also been consumed by the autopilot, and it has also been created in autopilot. And we will see the execution in a minute. So here it is. So 8112 is the ticket number. Let me just reconfirm. Yeah, it is 8112 is the last ending digit. And I will start the play button. So as you can see, the simulation has started happening. The ticket has been created, has been originated on the CentOS node. It has been consumed by the engine. The engine is trying to search for the knowledge item, and after that it is going into the step. As you can see, the step is to prepare the checks. It is checking for the service status. The moment it checks the service is down, it would bring the service back up, and it would notify the owner of the CI by sending an email. After the mail has been sent, the issue has been resolved. So the final status is, as we can see, the issue is in the resolve state. Right, so that's a quick demonstration of how autopilot or how automation executes on a given situation, how it executes quickly on a given situation in IT infrastructure. So one more important thing which I wanted to bring up is, as you can see in the ticket, how a human engineer would process the ticket. He would update the logs, he would update the comments, right? So from autopilot perspective, we have done all the required updates. So it started with updating the system information, like it assigned to the in-vivo group. It gave the appropriate impact, priority, and status. Right, it updated the resources, it updated the assignment, and moved the ticket to the right group. Right, and at the end, it also updated with a log. So this is the log. Whatever execution was being done by the automation engine, it records a history in the log file, and we will open the log file in a minute. Also, you can see in autopilot, as I explained. It creates an issue ID. So this is the issue ID from autopilot perspective. The same incident has been transformed into an issue ID in autopilot, right? And then we will see the logs. So this is basically the technical logs. It comprises of all the backend execution that the autopilot did. All the required execute commands have been recorded, right? So whatever sequence we saw in the replay has been recorded in the form of commands, right? So this is the history which the human engineer can also view for reference. Alright, so that ends the SQL Server use case, MySQL Server use case. We will move on to the next use case in a minute.